Hi everyone, welcome back to the channel. Today we are going to demystify one of the most important but often confusing parts of radiation therapy planning: how your CT, RTStruct, RTPLAN, and RTDOSE files are all tied together behind the scenes. These four file types form the foundation of treatment planning, and making sure they are properly linked is critical for accuracy, safety, and compatibility. Let's start with the big four. CT defines the patient geometry. RTStruct holds your ROI contours. RTPLAN contains the beam setup and prescription. RTDOSE stores the calculated dose distribution. All four need to be in sync for treatment to work correctly. What keeps everything aligned is the frame of reference UID. It's in tag 00200052. Think of it as the glue that connects CT, RTStruct, RTPLAN, and RTDOSE. Let's zoom in on how RTStruct connects back to CT. The frame of reference UID appears at multiple levels inside the RTStruct to ensure robustness. While some systems tolerate a mismatch at the top level, the UID inside each individual ROI under tag 30060020 and then 30060024 must match the CT for proper alignment. And here you see is the RTStruct DICOM header. The first one, the SOP class UID, this thing always referred to RTStruct DICOM file. And the second line is the specific instance UID of this specific RTStruct file. It has a frame of reference UID, and later we will see it's consistent with the frame of reference UID used in all other three items. The frame of reference UID appear both in the top level and in the lower level. And here, under the structure set ROI sequence, if this reference frame of reference UID does not match the true frame of reference, the link will break. Additionally, the ROI contour sequence will link back to the CT image. And here, the reference SOP class UID, this always meaning it's a CT image. And the SOP instance UID refers to the specific instance UID of the CT image. Next, the RTPLAN links to the RTStruct via tag 300C0060, which is the reference structure set UID. If this is broken or missing, the plan won't be able to find the structure set, even if the frame of reference matches. Most treatment planning systems don't enforce this link strictly, but it's essential if you want geometry and dose to align. So here, this SOP class UID end with 481.5 is always referred to DICOM RTPLAN object, and this is this RTPLAN specific instance UID, and you can see the frame of reference here matches with the RTPLAN, RTDOSE, and RTStruct, and also the RTPLAN will reference back to the structure set with the SOP class UID, and this 481.3 always means a DICOM RTStruct object, and this UID will be specific to the RTStruct UID, and we can go back to the other slides, and if we remember 11606, and you can see this is exactly the RTStruct being linked in these 4 objects. Next is the RTDOSE to RTPLAN link. The RTDOSE file points back to the RTPLAN using tag 300C0002, the reference RTPLAN UID. RTDOSE must have the same frame of reference UID as the CT. If not, the DOSE won't overlay, or worse, the system might crash when trying to open. So again, we see this is the same frame reference UID of all DICOM objects, and the RTPLAN will specifically reference, the RTDOSE will specifically reference to the RTPLAN, and this SOP class UID for a 1.5 always meaning it's a RTPLAN object, and this 40716 is the specific RTPLAN instance UID, and we can go back to check our RTPLAN. This is the same instance UID 40716, and it's the same here referenced by the RTDOSE. So to recap, the frame of reference UID 0020-0052 must be consistent across all 4 datasets. This is what keeps the patient anatomy, structures, beams, and dose all in the right place. Not all systems enforce it strictly in RTStruct or RTPLAN, but RTDOSE does. If this is wrong, the DOSE display will break. So what can you do? Always validate these 3 things: frame of reference UID across all files, SOP instance UIDs between referencing and referenced objects. RTStruct references actual CT slices in each structure set ROI sequence. That the dose grid overlays correctly on the CT. Next, let's switch gears for the live demo. Now that we understand how these files are supposed to link together, let's take a look at the Python tool I created that checks all these relationships automatically. Let's first run it in a folder that contains uncorrupted CT, RTStruct, RTPLAN, and RTDOSE set. As expected, all UIDs matches. Next, let's run in a folder where I intentionally corrupt one DICOM RT object reference UID. And here we can see it catches the inconsistency. Want to automate these checks? I built Python scripts to validate UID integrity and DICOM link consistency. You can download them from the link in the description below. Don't forget to like, subscribe, and leave a comment if you found this helpful. I'll be posting more DICOM scripting tips and tools very soon. See you next time. Bye.